Hello everybody at Phi Week. Welcome to my presentation. I will be talking about the Geo-Informed project. In this project, we want to unlock the potential of freely available Copernicus data, satellite imagery, for environmental monitoring, and we will do this through spatio-spectrotemporal deep learning. We can no longer ignore the negative impact we as humans are having on our living environments through pesticide usage, overconsumption, groundwater depletion, land use change, and many others. And this is causing us to experience climate change, biodiversity loss, and the potentially toxic pollution of our soils, water, and air. In this project, we want to create information that environmental policymakers can use to make better decisions and to monitor their policy outcomes. We selected the environmental issues that we would focus on based on the suggestions from the end users themselves. And these end users are all agencies that are involved with environmental policy in Flanders, the north of Belgium, and that's also our study site for this project. We started with an online questionnaire where the end users could propose any issue they were facing in environmental policy. We then did a feasibility assessment and ended up with a short list of 15 use cases. In a workshop with the end users, we finally decided to focus on 8 of these cases. The 8 cases we selected are listed here. They are related to the 3 overarching themes in our project, which is vegetation, water, and environmental pressures. Case 1 will focus on land use mapping in natural areas. Case 2 focuses on forest monitoring. In case 3, we will aim to detect damage by wild boars in maize and grasslands. Case 4 aims to detect building activities in a buffer zone around watercourses where these activities are not allowed. In case 5, we will try to monitor winter crops that can capture nitrogen in agricultural fields. Case 6 focuses on the detection of algae blooms in water bodies. In case 7, we will make an assessment of the fire risks in natural areas. And in case 8, we will try to monitor the presence and outline of stagnant water bodies in Flanders. As was already clear from the title of my presentation, we will use Sentinel images from the Copernicus program, and we will combine them with deep learning models to model the parameters that the end users indicated as important in the 8 selected use cases shown before. 4 main challenges are associated with the use of deep learning on satellite data and also especially for environmental applications. The first one stems from the fact that deep learning, and especially convolutional neural networks, often rely on high spatial detail. Sentinel data, however, has a spatial resolution of 10 or 20 meters, so we will have to rely on spatiotemporal deep learning to overcome this challenge. The second challenge is the presence of data gaps in the optical Sentinel-2 time series. Deep learning works best when the input series are identical for each location and each date. We can use the CropSAR deep learning-based algorithm developed by Vito to fill the gaps in the optical Sentinel-2 imagery with data from the radar Sentinel-1 mission. The third challenge is the limited amount of reference data that is typically associated with many environmental topics. Collecting ground truth is a time and resource intensive activity, and natural areas may not always be accessible from the ground. We can implement transfer learning, where a base model is trained on a general or global dataset and is then refined to the actual use case afterwards. And finally, if we want to build operational workflows for environmental policy, we need to ensure that the end users can understand and also quantify the uncertainties that are associated with our model outputs. Throughout this project, we will thus also work on the integration of Bayesian uncertainty estimation into deep learning models. Of course, there is a lot more to say about this subject, and you can find more information about what exactly we are doing and about our use cases on our website, which is shown here. And if you have any questions, you can ask them now, or you can send me an email. Find my email address on this slide. Thank you very much for your attention.